Okay, in this lesson we're going to review the sine law. The sine law can be used to find the lengths of missing sides and angles in non-right triangles. And there are two versions of the sine law, although they are exactly the same and can be used interchangeably. But we do often see two different versions. Okay, one version has the angle measures in the numerators across the formula. And that's the one I would use if you were finding an angle. Okay, so let's make a note here. Finding angles. And the second version here, I would recommend using if you are finding the measure of a missing side. Okay, so finding sides. So basically, the piece of information you're trying to solve for, it will make your life a little bit easier if that missing piece of information is in the numerator. Okay, having said that, either formula can be used in any case. What you do need in order to be able to use the sine law is the measure of a side and its corresponding angle. So say these two here. Okay, so we need to know a matching pair before we can use the sine law. So for example, in example 1, we are asked to find the measure of angle R. Okay, we know the length of side R, and we also know the measure of angle Q and side Q. So we're solving for angle R, so I'm going to write my own little version of the sine law here because my letters are not A, B, and C, they're R, P, and Q. So we're going to say sine R over R is equal to sine Q over Q. And I don't need the third part of the formula, sine P over P, because I don't know either piece of information for angle P or side P, and nor am I looking for it. Okay, so it's irrelevant in this case. We only need the first two parts. Fill in the information we know. So we know that side R is 9.5 centimeters. We know that, let's fix that up a little bit. We know that, hello, stylus pen. There we go. We know that angle Q is 53 degrees, so sine 53 over, and we know that side Q is 8.2 centimeters. So we filled in all the information that we know. Now, in order to solve for side R, we're going to cross multiply. So we'll have 8.2 sine R on one side of the equal sign, and 9.5 sine 53. Make that a little clearer. On the other side of the equal sign. Divide both sides by 8.2 to get sine R by itself. Oh, this is frustrating me tonight. Okay, sine R. Now, when you type in all these numbers on the left-hand side of the equal sign, I'm sorry, the right-hand side of the equal sign. Oh, for goodness sakes. There we go. You get a very long decimal number, 0.925248, and it continues on. Basically, leave all those digits on your calculator screen, okay? Write down at least 5 of them, I would say. And since we're solving for the measure of the missing angle, we're going to use the sine inverse button on your calculator. I think I missed a 2 in there, didn't I? So sine inverse, and that tells us that R is approximately 68 degrees. Okay, let's go through an example of using the sine law to find the measure of a missing side. So since we are asked to find the measure of side n, okay, I'm going to begin by writing n over sine n in my formula. Now on the other side of the equal sign, I need to have a side and angle that I already know. And if you look at the picture, you'll see that there isn't a matching side and angle that we know. We know the measure of side L is 15 centimeters, but we don't know the measure of angle L. However, we do know the angle measure for the other two angles in the triangle. So if we subtract them from 180, we could find the measure of angle L. So 180 minus 60 minus 40 tells us that angle L is 80 degrees. So now on the other side of the equal sign in my formula, I'll be able to use L and sine L. Okay, we'll fill in the information we know then. So we know the angle N is 60 degrees. L is 15 centimeters. And sine L would be sine 80. All right, once again, cross multiply. So we'll have N sine 80 equals 15 sine 60. Divide both sides by sine 80. Type that all into your calculator. So N is approximately 13.2 centimeters. Okay, we'll go through one more example, which is a word problem. It says 2 ships can be seen from a lighthouse. The distance between the ships is 23 kilometers. How far is each ship from the lighthouse? However, I realize now that your diagram is missing. So we need to create the diagram here. All right, so we've got ship A and ship B and a lighthouse down here. The distance between the ships is 23 kilometers, but what was also missing here is the angle measures. So we can't solve anything without those. So we've got a 40-degree angle and a 58-degree angle in this picture. All right, we're going to say X is the distance that ship A is from the lighthouse, and Y is the distance of ship B from the lighthouse. Now, this is another case where if I'm solving for side X or side Y, I will need to use the given side and its corresponding angle in the sine law. So once again, I need to find the measure of that third angle. So 180 minus 40 minus 58 tells me that the third angle in this triangle is 82 degrees. Okay, so now if I'm going to solve for the measure of X, the distance the first ship is from the lighthouse, we'll say X over sine 58 is equal to 23 over sine 82. And we'll worry about Y in a minute. Cross multiply. So X sine 82 equals 23 sine 58. Divide both sides by sine 82. And that tells us X is 19.7. So ship A is 19.7 kilometers from the lighthouse. Okay, and now we're going to do the same thing to find the distance for ship B. So for ship B, we're going to say Y over sine 40 is equal to, and once again we'll use 23 and sine 82. Okay, cross multiply. So Y sine 82 equals 23 sine 40. Divide both sides by sine 82. Type that all into your calculator. And I believe that one is 14.9 kilometers. Okay, so we'll say, therefore, the ships are 19.7 kilometers and 14.9 kilometers from the lighthouse. And that concludes your sign law lesson.